Assalamualaikum and good morning. Today our group would like to present about adaptive cruise control. So our group member is made up of 5 person. I am the first person to make a presentation. So I will carry on my presentation slide. So what is cruise control? Cruise control is a concept of assisting driver in two of longitude while control. The idea of driver assist was started in 1970 in USA by calling it cruise control device. Cruise control device of 70s and 80s. Now, it has reached to corporate adaptive cruise control. You can look at the block diagram. You will see LiDAR, sensors. They will send the digital sensor, digital signal processor to the sensor fusion object recognized. And cruise control also got camera. So left camera and right camera will process the image to also to the sensor fusion objective. Then it will go to the objective of classification. It will make every class and decision will make by the engine. Why we choose adapt cruise control? This is a good question. Every day the media bring us the horrible news on road accidents. Once a report say that the damaged property and other costs may equal 3% of the world gross domestic product. Moreover, the death on the street account for more than 17% of total death around the world. That means 100% die in one day. 17% is die on the road. The conventional cruise control was capable only to maintain a safe speed by accelerating or decelerating the vehicle ahead, by control the engine, throttle and brake according to the sensor data about the vehicle. Working on SCC. First, set speed, switch on SCC, sensor detect vehicle ahead, deceleration to ahead vehicle speed, keep safety distance, collision or avoid system. Operation principle of SCC. The SCC is set by the driver. A radar sensor is the core of SCC. It installed location at front of vehicle to permanently monitor the route clearly.
Okay, I will present my part is a sensor option. Currently, format of object detection are technically feasible application in a vehicle environment. They are radar, LiDAR, vision sensor and electronic sensor. Sensor option. Radar is operated by radiation energy into space and detecting the echo signal reflect from target. LiDAR is a laser diode was used to generate the light signal. Vision sensor and electronic sensor. Advantage: it is very useful for long driving, can avoid unnecessarily violating speed limit, is reduction in accident rate, reduction in driver fatigue and increased fuel efficiency. Development of SCC which already in today market. It has stop and go adaptive cruise control. It works primarily at lower speed in heavy traffic. If the car is in front stop, it will bring vehicle to complete stop. It a cooperative adaptive cruise controls. The function is to preceding vehicle can communicate actively with the following vehicle so that the speed can be coordinated by each other. Stop and go adaptive cruise control. Continuously measure the present gap distance of the vehicle in front when it is within close range. Can automatically apply the brake when the system detect the car in front. Can bring the vehicle to a complete stop if the driver fail to apply the brake in time. It help the driver potentially avoid to reduce the severity of collision. Keep the car at a complete stop without the driver having press a pedal. Return and the last one is return the vehicle to its preset when the driver tap to resume button. We'll pass my slide to Shahrul. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I am Shahrul Haizat bin Mohd Khairudin. I'm gonna continue from the previous slide. So the system can warn the driver if it detects the possibility of the collision. The system uses distance indication, distance alert and active braking. During adaptive cruise control and pre-collision analysis, the brake will be in standby mode. If the driver fails to react, then the brake will start to brake to to help the vehicle slow down. Then it will slow the vehicle 30 miles per hour below its current speed. This system also has developed the pedestrian detection where it can detect the pedestrian beside the road. It alerts the driver with a warning light and audio warning. Then the system will slow down as before procedure. Cooperative adaptive cruise control same as the adaptive cruise control, but it has improved the stability by reducing the delay of the response to proceeding the vehicle. This system utilizes vehicle-to-vehicle communication with the wireless technology. This system can reduce the time to detect the front car and incoming car and calculate the parameters such as position, velocity and acceleration before it braking. However, adaptive cruise control has limitation which is bad for a tired and sleepy driver hard to slow down the vehicle quickly. Secondly, it is not suitable in a bad weather where the tire lose traction for braking. After study has carried out, both adaptive cruise control has problem where we can conclude. First, weather effect is not efficient on a bad weather because of blinded sensor due to fogging, raining or snow condition. Second, traffic problem, it is unable to detect the traffic environment and fail to recognize the traffic signal. Third limitation of sensing is unable to predict the hazards such as minor flood and road defect. Fourth is inconvenient for all because of expensive devices. Lastly, limitation of view where it unable to detect a car came from a sudden junction. I will pass to Vasnth.
Alright, thanks to previous presenter Shahrul, and good day doctor, my name is Vasnth. My matrical number is MH20005. So, in this slide today, I'm going to present about our innovation, or we are optimized a system from previous ACC, which is collisions avoidance assistant with intelligent environment friendly vehicle. In shortly we call that IEFV CAA. This system helps avoid obstacles at emergency high-speed situation by employing the conventional driving in loop driving system and assist driving with multiple objectives such as traffic safety, energy optimization, and environmental protection. This system also will more efficiently during heavy weather, or we call bad weather. In traditional ACC, we can conclude that when it's bad weather or heavy raining or foggy, which is lead to our traditional ACC in failure. Let me explain how the system is actually work. IEFVs use such technologies as radar sensing and camera in advanced driver assistance system, or network communication among vehicle to obtain information such as presence of obstacle from the road environment. On detecting a collision risk, the controller determines the target path and compare it with actual vehicle path. The IEFV environment comprises several components such as pedestrian, road conditions, traffic condition, weather, and vehicle status. Image processing application in vehicles include lane recognitions and obstacles recognitions. This is the system analysis of emergency CAA in IEFV. Environment and driving behavior recognitions, CA decision making and path planning, path tracking, and human machine share control. These are the diagrams which explain the flow of the systems step by step. Thank you very much. I will pass this slide to next presenter.
Assalamualaikum and very good evening to all. My name is Firdaus bin Nazarudin and my matric number is MH20009, and I'm going to be presenting about innovation makes ACC more efficient. Okay, firstly, IEFV will overcome the problem from ACC mode with more safety feature that will make the car overcome the hazard with traction control and will balance the tire movement so that it does not slip and it crosses the slippery road safely. Okay, so IEFV stands for environmental friendly vehicle. Okay. The second one is adaptive cruise control can use in any kind of weather by upgrading the new features that makes a connection to wheel speed sensor and traction control system. Okay, during cars through snowy, wet and icy road, condition of the wheel speed sensor will detect an unusual speed on one of the 4 tire and it will send the signal to ECU, and then it will send the signal to traction control system in order to control the tire in snowy, wet or icy road condition in the adaptive cruise control mode. As you can see the below diagram below, with ACC with IEFV, when it hits the slippery road, the driver can control the car. Without the IEFV, the driver lose control of the car on icy or snowy road. And then with IEFV, ACC will overcome the bad road surface in heavy traffic and make the ACC system cannot respond directly to the traffic signal with cameras in advanced driver assistance, which is ADAS, which can warn or assist the driver, even control the vehicle automatically in dangerous situation. We detect a collision risk and the controller determines the target path and compares it with the actual vehicle path. System are active safely. The system that the controller evaluates the adequacy of the driver's braking and steering. Okay, and then based on the characteristics, colors and texture, those based on road curvy parameters, straight lines or linear parabolic curves. And then the histogram of gradient method is used for pedestrian features extraction and uses 3D infrared image. Then based on hierarchical matching algorithm on outline, combine pedestrian vehicle lane detection and set the triangular region formed by 2 lane divider. As you can see below diagram, on foggy condition, with ICC you can see the line of the road. With the ICC you can't see anything. On rainy day you can see the clear path of the road. Without ICC you can see anything. That's all for us. Thank you.